Assalamualaikum. Today I will talk about introduction about LV and ELV system. Building service engineering ensures safe, efficient and reliable operation of modern public buildings. Second, LV and ELV system support lighting, power distribution, communication, security, monitoring and emergency service. The purpose for story public service building include office, service, counter, meeting rooms, server room, hall and external facility. The fourth is electrical system must support various load such as air condition, ICT equipment, CCTV, access control, PA system and queue management system. And then the next slide is another introduction. Proper LV distribution using MSB, SSB, DB, protective device and cable routing it required for stable power supply. The second is critical areas such as server rooms and security system required continuous and reliable electrical supply. And then another is safety feature including MCB, PCB, grounding system and cable management help prevent electrical hazard. ELV system improve communication, security, monitoring and emergency response efficiency. And then the system design must complete with Malaysian standard will support energy efficient, sustainability and feature impression. The last one is this report indicate the most suitable electrical building service system for effective building management. Thank you.
So I will be explaining about the building background of this urban Kangar. Urban Kangar located in Jalan Raja Sa'alwi Perlis. Year of construction between 2025 until 2026, and the owner of this building is Majlis Perbandaran Kangar MPKA. The operating hours for the building is 8 AM to 5 PM, Monday to Friday. So this building, the concept of the building is one stop center, and it was a centralized hub for JPN, JIM, LHDN and JPG under 6,800 meter square reinforced concrete roof. So I will be explaining about each detail for each level. So we will start with ground level. It was designed for high traffic. The primary entry point features a large waiting hall for 150 people. Advanced digital queue management ensures smooth flow and real-time ticket display. It has a security checkpoint, digital integration and access. So we will move into the first level. First level is the hub of administration. This floor acts as the nerve center of MKA. Accessibility only at authorized individual. It consists a combination of open space workstation which encourage teamwork and personal executive suite for top executive. 3 sophisticated meeting room and with state-of-the-art audiovisual technology and video conferencing are provided on this floor for administrative and planning purposes. Entry to this floor is controlled by electronic access system at both the elevator lobby and the stairway entry point. So we move to the second floor, the digital break. The second floor of Urban Kangar consists a highly secure staff-only area that acts as the brain center of the entire technology system of the building. This area comprises the server room of crucial importance, where the system runs uninterruptedly using uninterrupted power supplies and industrial networking switch. The other side of the floor is dedicated to the storage of confidential physics and digital files of JPN, JIM, LHDN and JPG. All the confidential information stored here is safeguarded using biometric access, environmental controls and sophisticated fire suppression system. So we will move to the third floor, community and learning. This level represents a multifunctional space used for the education purpose and community gathering. It includes a training room that can hold 18 people and offers computerized working space. The main feature of this floor is the multi-purpose hall designed to fit 150 people, where ceremonies, exhibition and briefing will take place. Such function involve large amount of energy needed for lighting and air conditioning. So there should be a power system that may vary in the future depending on technological development in the building. And we will move to the external infrastructure. The integrate security command, the external perimeter is anchored by a central guardhouse command post. The guardhouse command post have a CCTV surveillance and control, automated gate system and digital security interlink for the safety of the building.
Hai semua, hari ini saya nak terangkan tentang installation practices for LB dan ALB system dalam desain bangunan yang kita pilih. So, yang first, LB system dalam distribution board, layout dan accessibility. Dikenali sebagai MSD, yang itu main switchboard. We position that MSB in a dedicated ground floor room right near the building entrances. Why we do that? Because it allows the utility company to easily direct access for incoming supply cables and also ensures emergency services and can also isolate main power instantly if needed. And then SSBs. What is SSBs? It is actually known as sub-switchboards. These are strategically placed in vertical risers to isolate different type of loads. For example, we separate continuous predictable loads like the first floor offices from intermittent or to high surge loads. This prevents power fluctuations on one floor to another floor. And then final distribution boards known as DBs. These are housed inside staff-only cupboards. Secara umumnya dibagi tahu sebagai restricted area. Yang area tu hanya boleh lalu oleh staff macam tu. This is a deliberate choice and it also ensures that quality or qualified technicians can perform routine maintenance safely without creating a hazard or a disruption in public areas. Okay, let's move to the next slide. This is about safety and protective devices. For example, RCCBs, which is residual current circuit breakers. This one usually placed in ground floor or lobby area. These devices constantly monitor current balance and will instantaneously trip if they detect even a tiny leakage to earth, effectively preventing fatal electrocution. And then MCBs. What is MCBs? MCBs is miniature circuit breakers. They are engineered to isolate only the specific faulty circuit. Let's say if someone plugs in a defective appliance in an office, only that specific breaker trips, leaving the rest of the floor completely unaffected. So, and then SPDs. SPDs is a surge protective devices. These devices act as shield, diverting massive voltage spikes, whether from lightning or utility switching, safely away from sensitive server racks. And then let's look for local isolators. Usually houses heavy which have heavy HVAC equipment and stage lighting. These local isolators are installed directly at these loads. It means the maintenance teams can safely lock out and service a specific AC unit or stage house without needing to shut down power to the entire floor. Let's move to the next slide, which is like IP-based CCTV networks utilizing power or Ethernet, or maybe something called as PoE, by running both data and power over a single Ethernet cable. We drastically can simplify the cabling infrastructure. All this footage is then fed back to a centralized network video recorder, and we have storage, and then access control system. This one is digitally linked directly to the intercom, CCTV, and also the fire alarm system, because in the event of emergency it directly gives signal to the system and then triggers fire alarm. So it will instantly unlock secure zones such as the server room or any other room, ensuring occupants can evacuate safely and emergency responders can move without any delay. And then public address system. This one is tied directly to the ground floor management system. So this allows for automated, clear announcements, optimizing traffic flow without requiring manual staff intervention. So we have like real-time power monitoring in high-use areas like training rooms or more upper floors. This gives facility managers the precise data they need to optimize energy consumption. So this building always needs advanced servers, like a proper installation practices of LV and AV system. So that's it. Thank you.
Good day, everyone. My name is HEMALATHA. Moving on to a recommendation of the proposal A versus proposal B. In this section, we conduct a comprehensive comparison between proposal A and proposal B across 6 critical engineering criteria to determine the most viable solution for this 4-story public service building. Let us evaluate them. Starting with our first criterion, system reliability and continuity. Proposal A relies on a basic configuration with a single primary distribution path and manual transfer switches for the backup generator. While this keeps initial costs low, it introduces a single point of failure and manual delays during a power outage. In contrast, Proposal B utilizes an automatic transfer switch connected to an uninterruptible power supply network. This guarantees an instantaneous, seamless power transition for critical areas like our server rooms and security system, ensuring zero data loss and absolute operational continuity. And the second thing is earthing and equipment protection. Proposal A features a standard conventional earthing system. While it meets minimum regulatory baselines, it lacks advanced isolation for highly sensitive extra low voltage equipment, which is ELV. Proposal B, however, implements a dedicated clean earthing system combined with localized surge protection devices at every subswitch ports. This design shields our delicate administrative servers and communication networks from transient voltage surges and electrical noise, minimizing equipment damage. Next, We have life safety and security integration. Under Proposal A, the fire alarm and public address systems operate on isolated localized loops requiring manual coordination during emergencies. Proposal B elevates life safety by fully integrating the ELV system. In the event of fire, the system automatically triggers emergency lighting, releases electronic access control doors for safe evacuation, and overrides the public address system to broadcast clear evacuation instructions. This integration drastically reduces emergency response times. Moving on to maintenance accessibility. Proposal A places several distribution boards in common hallways and public corridors. Conducting routine thermal scanning or repairs here risk blocking public traffic and disrupting daily service operations. Proposal B solves this by housing distribution boards within dedicated service cupboards accessible only to technical staff. Furthermore, by installing local isolators for HVAC units and stage lighting on the third floor, maintenance team can isolate and service specific machinery independently without shutting down power to an entire floor. Our fifth criterion is future expansion and scalability. Proposal A is designed right up to the current estimated load capacity, meaning any future building upgrades or new technological integrations would require a costly overhaul for the primary switchboards. Proposal B proactively incorporates a 25% extra spare capacity across the entire distribution network. This allows the local government to easily expand services, add public counters, or upgrade IT infrastructure in the future with minimal modifications and zero structural downtime. Finally, let's look at the energy management. Proposal A features standard mechanical metering, which only tracks total building consumption at the end of the month, making it difficult to spot energy waste. Meanwhile, Proposal B introduced smart real-time power consumption monitoring at every switchboard. This allows facility management to track live energy footprints, identify high consumption zones, and implement targeted energy saving policies to optimize overall building efficiency. In conclusion, while Proposal A offers a lower upfront capital investment, it lacks the resilience, safety features, and adaptability required for a modern public facility. Therefore, based on our rigorous engineering assessment, we firmly choose Proposal B. Its superior reliability, enhanced public safety integration, seamless maintenance access, and 25% built-in future expansion capacity make it the most sustainable, high-value, and forward compatible solution for the local government. Thank you.
Assalamualaikum, saya Muhammad Ameer bin Muhammad ASHAARI. Nombor matrik saya 2413334110 akan sambung dengan Section D, Supervision Framework. Supervision Framework ensuring high quality installation, rigorous site inspection and effective contractor coordination. Site and material inspection. Tier protection. Verify the accelerator RCCBS and MCBS are installed at design level to provide comprehensive tier protection across the 4-story structure. And the second one is safe installation. Ensure distribution, both DB and MB are accessible and unobstructed, facilitating ease of maintenance and future expansion. Next is cable routing and segregation. Signal integrity management, detailed supervision during trunking installation is critical to maintain physical segregation between LV power and ELV data line. Impact of this is prevent electromagnetic interference, ensuring optimal performance for IP, CCTV, and high-speed network stream. Next is the testing and commissioning TNC. The first one is LV technical testing. Continuity and installation resistance tests are mandatory to prevent short circuit and leakage before building energization. The second one is life safety RCCB. Verification of trip time to meet Malaysian safety regulation and protect user from electrocution. The third one is integrated ELV. Fail-safe test, interface and control door automate auto control door to release automatically during emergency. Next is the ELV integration performance. This integration is 100% fail-safe release. This is bandwidth and connectivity, ping test and bandwidth verification for all PoE camera, high definition stream handling from car park, PS system integration with ground floor and queue management. Next is energy efficiency and monitoring. Real-time tracking of energy consumption to meet goal. Power quality monitoring to protect service server, sensitive server room equipment. Continuous performance tracking through advanced tool. Next, next is the maintenance and security planning. Continuous operation MSB and DB arrangement allow maintenance access without total building shutdown, protecting administrative function. As-built accuracy. Future expansion provision document to guide engineering team as public need grow. Cybersecurity. Regular software firmware update for IP-based CCTV to mitigate risk and ensure reliability. Intruder alarm. Immediate alert for breaches in critical space like server and record room. Next is the regulatory and safety impact. The first one is impact of compliance. Strategic requirement is TNC reporting and legal significance of it is required for CCC in Malaysia. The second one is health and safety. For its strategic requirement is protective supervision, preventing fire and electrocution. Impact of the third is sustainability. Strategic requirement asset monitoring, reducing environmental corruption footprint. The fourth one is operational and the strategic requirement is maintenance access, extending asset life cycle. For the last one is societal impact highlight. The first one, public safety, integrated security system create a safer environment for visitor and staff. The second one is reliability, state stable to server room and critical administrative record room. And third one is efficiency, improve visitor and faster emergency response coordination. Thank you.
Hello, my name is Puteri SYASYABILA TUAN ZAMANI. Today I would like to present about the impact by implementation of low voltage and an extra low voltage system in Proposal B to 4-story of public building. First, let us look at the societal impact of Proposal B. This proposal brings significant benefit to society by improving public safety through integrated security system. It also provides better operational efficiency and service reliability. The integrated system operates more efficiently and helps reduce risks such as unauthorized access, theft, and safety issues. Systems such as IP-based CCTV, access control, and intercom system improve security monitoring and allow faster emergency response. This operation also enhance user comforts and confidence while using the building. Next, we will discuss the health and safety impact. The proposal B, enhance health and safety impact through improved electrical protection and emergency system. The installation of RCBS and MCBS and insulator provide better electrical protection throughout the building. RCCBS help detect leakage current and automatically disconnect the power supply during faults, this reducing the risk of electric shock. Meanwhile, MCBS protect the system against overload and short circuits. It help prevent fire hazard and equipment damage. Proposal B also improve emergency communication and evacuation. Integrated of ELV system such as CCTV, intruder alarms, access control and PA system also strengthen emergency preparedness during emergency. During the emergency, the PA system can provide clear evacuation instruction, while the access control system supports safer evacuation through the emergency door release. It also provides safer maintenance procedure and better protection for occupants and technicians. Isolators improve maintenance safety by allowing technicians to disconnect equipment before carrying out maintenance work. Proper cable routing and separation between LV and ELV system also reduce electromagnetic interference that may affect CCTV and communication system. Moving on to the legal impact. Proposal B is designed according to Malaysian Regulation Engineering Standard and safety requirement related to electrical and building service engineering. Compliance with Suruhanjaya Tenaga requirement and relevant Malaysia standard help reduce legal risk and ensure proper installation procedure. The supervision of LV system such as MSB, SSB, DB, RCBB, MCB and insulators ensures that electrical installations are safe, accessible and suitable for maintenance and inspection. The integration of CCTV system, access control system and fire alarm interference also support compliance with Uniform Building Bylaw UBBL and modern building safety requirement. Regular contractor meeting further improve coordination and ensure all systems are installed safely and professionally. Now, let us proceed to environmental impact. The proposed LV and ELV system contribute to environmental sustainability through improved energy efficiency and reduced electrical wastage. The LV distribution system using MSB, SSB and DB help minimize unnecessary power losses and improve overall electrical performance. Proper cable routing and supervision during installation also reduce installation error that may affect system efficiency. Meanwhile, IP-based CCTV and access control system support smarter building operation and better energy management. The implementation of LV and ELV system in Proposal B give lower environmental impact and smarter energy management. Last but not least, let us discuss the sustainability impact. Proposal B provide easier further expansion and upgrading. And next, improve long-term operational reliability, reduce maintenance costs and downtime for a long time, and provide better integration with further smart building technologies.
I will present the last part for our slide. It's about conclusion. first conclusion is Proposal B is the best solution for the 4-story urban Kangar public service building, provides safer, more reliable, efficient and sustainable LV and ELV system, better power distribution through a proper MSB, SSB and DB arrangement, improve hole installation, reduce risks of total power failure, safety adjustment with RCCB, MCB, isolated and such a protection device. ELV system include first one is IP based CCTV, second one is access control, and the third one is intercom, and then fire alarm interface, public address system, and the last part is queue management system. Another part for conclusion for our PBL, improve building security, communication and energy response, easy maintenance, monitoring testing and feature expansion, support energy efficiency and smart building integration, high initial cost but provide long-term benefit. We have 4 long-term benefit. For the first benefit is better safety. The second one benefit is lower maintenance cost, and then third one is operational continuity. The last part for our benefit is feature flexibility. Final statement: Proposal B offer the most effective, safe and feature-ready electrical solution for the urban Kangar public service building project.